be after the digital factory. One will be after, let's say, the market-oriented factory. How does a plant try to be close to market? And the third part will be after the sustainable factory. Okay, the third part, I introduced it 3 years ago. For your information, it's a course that I'm doing as well at ISAE Super-Héros with a slightly different perspective, a little bit more technical. And since 3 years with the growing consciousness of the climate change, and even more with the COVID-19, I've been a lot updating this course. So I hope it will give you some insight to understand how the aerospace COVID-19 crisis. Digital world. First, there's no digital strategy. Be sure of that. There are business strategy that take into account the fact we live in a digital world, but no digital strategy. Digital is a tool. It's only a tool. It cannot be a strategy in itself. Why do we have this? The starting point is the digital data, 1.0. It has three main features. It has integrity. You can copy it, you can replicate it, and you can send it, transmit it to someone else. Because of these three features, the digital data 1.0 is taken in an acceleration and transformation that goes through the growing ways to connect people and objects. There are more and more physical and living bodies that are connected to internet. Well, human beings, sorry, objects and human beings that have an internet connection. And besides this growing number of communicating points, there is a growing programming power. When I say growing, it's growing exponentially. And also, we are having increasing behavior in sharing the data. Not only people, but also machine. Machines are more and more sharing the massive flow of data that is fabricated, that is generated inside the machines. This growth is exponential. It will not be the subject of my course, but for your information, the carbon footprint of digital market is 2 times that of aerospace. I'm sure you've heard about the carbon footprint of aerospace over this 2020 year. It has been a lot criticized. There has been a lot of aerospace bashing. So keep in mind, digital is twice. Aerospace is 2.5% worldwide. Digital is 4.5%, close to twice. And second, the growth is twice. The growth of aerospace is 5% worldwide. The growth of digital is close to 9%. So one thing I'm sure is that it is a market that will have tough time one day. It's definitely not sustainable the way we are growing. Okay? But anyway, that's how it is today. Exponential growth in the sharing of data, in the production of data, in the use of data. What do we do with data in the factory? The first thing to do before talking about digital data, about digitalization, is to realize that in factories, there are creation of data. In industries, there are creation of data from what I would call IT master system, in opposition to slave system. Digital tools are slave system. They capture the data, they transmit, they copy, they share, they don't create, not digital tools. The tools that are creating the data are the tools, the IT master tools, which are designed to make specific transaction in the industrial company. So on this slide, you have a representation of the typical areas of data created and monitored within an industrial company. If we start on the shop floor, what I would call level 1 and 2 in a plant, you have those systems, manufacturing execution system, MES. You have product lifecycle management system. You have digital mockup, DMU. You have CAD/CAM, computer assisted design, computer assisted manufacturing system. These are used to basically monitor instant data of shop floor transactions, machine to machine, man to machine, in order to produce the different products. Okay, so it's more the world of instant data, many data, but short lifetime of data, short size of data, numerous one. Then we have the level 3, which we could call shop floor execution. This horizon scale is more that of the hour and the day. At this level, we are more doing analytics and transactionals. We are using also manufacturing execution systems. We are using also PLM, ERP, enterprise resource planning, and we start to use BI. You may have heard of that, BI tools. This is a digital tool, okay, business intelligence. So BI is what you do, for instance, on your smartphone when you are looking at your bank account, trying to organize your expenses of the last month between what you paid for food, what you paid for leisure. This is a BI application that is capturing all the data from the servers of your bank, and it's using calculation rules to display in a user-friendly way the results. This is BI, okay? It's not creating data. It's not erasing. It's just capturing and making calculation and putting in a user-friendly format. Then you have the level 4, which is what we could call the plant monitoring level, which is using ERP and PLM. So as you can see, and this level is more with the horizon of weeks and years. The plant manager is not going to the single quality data of the machine X57 in the shop floor, okay? With this, you understand that depending what we want to do, depending the level of organization in the plant, we are not using the same IT system for the same transaction, okay? And you've seen that I have not spoken a lot about digital. I have told you a lot about what I call the IT master system, which are those that we've already seen in one of the previous course. So they are the blue systems, okay? And those blue systems which are creating data, recording the data, managing the updates, the valid version of each data, because data can be updated. These master systems are helping the company to manage the information flow in orange that goes parallel with the physical flow in red, okay? The physical flow from the place of production, the shop floor, to the external world that will consume these products, okay? Going through buffers. And this information flow, these IT master systems are connected to the external world, okay? And where's the digital tools? The digital tools are more a layer that is on top of all these, helping to capture the data. We'll see that later on. Another illustration of IT system is this computer assisted design, computer assisted manufacturing chain that enable to move from a CAD model, a virtual 3D model of a product that is not existing today, down to the production of the first part with 100% conformity. So this is made by a combination of different IT solutions that we call CAD/CAM, nothing to do with digital. And this is more than 20 years old in companies. This is the example of a software program that will machine this part. It's an aluminum bracket that will be used to build airframe from an aluminum blank. So you can imagine a piece of aluminum has been cut to this shape, and the yellow area is the progressive cut made by the tool, you see the small cylinder, in the NC machine. So this is completely, the result, this program of a CAM, computer assisted manufacturing software, which is connected to the CAD, computer assisted design software, and that enable to move from the product design to the first produced part. Back to digital. Where is digital? First, if we consider the company, the center place of digital will be the product. So if we consider, for example, Boeing company producing aircraft, the core of the digital, I would say, way of working will be to develop and use a connected aircraft. Around this connected aircraft that will enable the company to capture a lot of data, to understand, to improve, around this, the company, let's say the Boeing company, will build digital manufacturing, we'll come back to it, will build data analytics capability that is very important because it's what enables you to understand, to find ideas, to find improvements out from a massive volume of data. If you don't have the analytics, you can't do anything. It's like looking for gold in a wide river. If you don't have the tool, you will not see the microgram of gold in the gold river. Okay, so data analytics is key. The company will also build digital workplace. It is work areas, can be virtual, can be physical, where employees are using digital tools to enlarge their working capabilities and get the benefit of the digital tools. Also, the company will set up digital functions, digital process, that is to say, new methods of working that are using the digital capability in order to develop products with a smarter and a shorter, in a smarter and shorter manner. I can take an example. A company developing a new plastic 30 years ago was developing the plastic only with physical tests in the car industry, for example. Okay. Now, a company that wants to develop a new plastic for a new car that will have, I don't know, a special steering wheel, and they want something special in the steering wheel, so they want to invent a plastic, a sustainable one, blah, blah, blah. This company will use a software that will use virtual models of plastics. This company will simulate if it is changing some ingredients of the plastic, some polymers, some different combinations of ingredients, and this company will simulate what are the properties of these simulated material, these simulated combinations. And the company might even give this simulation to a plastic injection company that is producing the steering wheel and ask this plastic injection company, can you simulate if you were injecting this virtual material in a virtual mold, if it would work correctly? All this is in a pure virtual working process, okay? That's an example. And how are those tools developed? First, you can see here, bottom of the slide, the five master systems I've already told you about several times. MES, ERP, CAD/CAM, PLM, and also EDI. This is the interface with the external world. So again, this is the foundation. If you don't have that, you can use digital, but you will produce nothing, no added value at all. On top of this master system, you have what people call usually a data lake. The data lake will be used to put all the data, whatever format, whatever morphology of the data. It can be a CAD model, so complex data, complex combination of many data. It can be single quality transactions. It can be warehouse issuance information. So all the data are going in the data lake. In the data lake, they can be pulled out, captured by the different tools that will use them to provide the benefit. What are those tools? The tools are here. On the slide, they call them the digital capability. So the tools are cloud, are data analytics, augmented reality, IoT, artificial intelligence. There are different kinds of tools. And last but not the least, to be able to use those tools in an efficient way for capturing the data that are in the data lake, you need to transform the mindset of people and the way people were working. Look at your grandmother or grandfather, okay? It's not as easy for them to use the iPhone or the Zoom as it is for you, because they have been used to communicating with different methods. Okay, so to support this change in the company will work on methodologies, design thinking, will work on areas like theater, iLab, showroom, to promote the new use of these digital tools and enable to develop improvements and set these I would say these capabilities. Okay, small example quickly. These are a few examples of prices evolution between 27, 28, and 2013, 14. So you can see that the digital objects are much more accessible to end users and companies. And this is a small video of Stelia Aerospace, where you will see several digital applications at research level. It's 3 years old. It's not only digital application, you will see a few others, but it's a little bit of interest. Okay, can you hear me back again?
Yes.
Yes.
Okay, could you hear and see or just see the video?
Just see.
Just see.
Okay.
Just see.
So when there will be text, I will comment myself. Most videos is only music, so you don't miss anything, but next time I will comment. Okay, so market-oriented factory. You can see the slide, it's okay? Back on your screen.
Yes.
Okay, so how is the factory close to the market? First, if we are back to the master IT system I told you about, the historical tool of the industrial company before digitalization, those tools, they are not really communicated with each other because they are designed for monitoring very different type of data. Think about CAD/CAM, it monitors a 3D model, okay? So it's really design oriented. Think about ERP, it monitors cost data, salaries, purchase order, sales orders, stock values. Nothing to do. I mean, look at the data, look at the data on your screen. It's totally heterogeneous data. Second, this tool, they are not analytics tool. You can't do analytics with an ERP or a CAD/CAM. It's not made for that. These tools, you do them to make transactions. That is to say, for example, the designer, once the 3D model is finished, will validate, and this validation will push its model to a kind of email address in the CAD/CAM software of a colleague, which is the one having the authority to validate a design. Once this validation engineer will have done its work by signing in the CAD/CAM system, it will be pushed to a third guy, for example, who will be responsible to test the load, so to verify that the validated design part can be submitted to a static and dynamic load and not break, not have cracks, and so on. This is what we call a workflows. So it's a combination of work actions, transactions that are made inside the tools. Okay? So these tools, ERP, CAD/CAM, they are not analytics tools, they are transactional tools. They support a working process between a chain of individuals that are, to a certain extent, customer and supplier to each other inside a company. And third, last but not the least, these tools, they are not just user-friendly. They don't offer a good visualization. Because of that, the IT infrastructures in the company over the last decade have been progressively upgraded with the data lake coming from the digital capabilities and with BI tools. Power BI is an example, Tableau is another one, Click is another one. There are many softwares of BI. And this has started to change. So this is the old ways of working. So people were taking in the ERP, SAP is an ERP, for example. So they were taking the data with Excel, the basic Microsoft Excel, yes, using a lot Excel. 100,000 of people in big companies are Excel users and not specialists of Excel. And out of Excel, making now PowerPoints, graphs, images to explain to the management. Now, with digital capabilities, companies are setting up a data lake, putting a Power BI tool on top of that to extract the data from the data lake, create the calculation rule, and use this to communicate, to make analytics and to communicate. And these capabilities enlarged to the global company and to the industrial ecosystem of the company is opening to many capability. Think of it. It was an aircraft 20 years ago. It has become a smart aircraft, and now it has become a system of systems because you have a connected aircraft around a connected environment of different users, suppliers, customers of product and services who are themselves connected as well. So this is enabling the whole industry ecosystem from suppliers to service in-life to in-life service organization, MRO, to be interconnected with their data and to reduce the cost of friction. And 2 years ago, Airbus estimated that in aerospace industries, we could save, if we were properly using digital capabilities, close to $55 billion yearly. That's close to the revenue of Airbus Commercial. So it's a big money. And how a company will take the benefit of this digital data? How will they save? We're back to the connected product. So it starts with the aircraft. In the aircraft, you have connections thanks to digital capabilities. So you can have a connected seat, you can have a connected engine, you can have a connected entertainment software, and all these connected objects are capturing data of activity, it's working, yes or not, data of efficiency, it's working well, or it's working not in an optimized manner, and many other. And these data are a value to drive improvement, okay? Because these data will enable the company producing the product, the seat, the engine, the entertainment system. It will enable the company to understand how the product has behaved, how it has been used, how it has failed, if there was any failure, what are the most used functions, and this will be analyzed using the data analytics, all the data captured by the object, and will enable the company to identify new product, new services, improvement of product, improvement of services. They will develop such, and they will integrate those improved capability in the end product. And these new products will come in use, be experienced, and so on. So that's why we are talking of the virtuous circle of digital. It is just that it's enabling the product to be always improved in a fast manner and to be improved starting from the market utilization. In complex industries such as aerospace, these capabilities are likely to drive us to a way of working that we call digital twins. What is digital twins? Digital twins is a complete new way of development that is using 3D tools to empower the industrial companies to, let's say, integrate the physical reality of products, plants, people, services with the virtual dimension of these products, people, plants, services. So it's like we would have two worlds. One is the digital world, okay, with the digital twins. In this world, you have products, you have 3D models of aircraft, not one 3D model of a single aisle, an A320 aircraft, but one 3D model of each and every A320 produced for Air France, produced for Air Asia, produced for Emirates, and not only one per aircraft number, one at the pre-design stage, one 3D model at pre-design stage, one 3D model at design validated stage, at stress validated stage, at certified, as prepared, as manufactured, as flying. So it's awfully wide and complex because it means that the 3D model would be defined and used and stored at each step of the product life and for each and every single product. So this is for the product, but you need to have in mind that this is also valid for the process. So it means that to manufacture this aircraft, we are using machines. So we would have also a 3D model of the machine with the mold, the tool, and the environment of the machine. Because around the machine, inside the machines, there are objects, there may be some people around, sometimes inside, depends the type of machine. And all this will be built as a 3D model to simulate, to understand, to interact. And this is also valid, last point, for the services. What kind of services? Consider the aircraft tomorrow. Maintenance services. The aircraft is at the airport on the ground. There needs to be a change, I don't know, let's say a change of panel. Make something, let's take something easy for you to understand. For changing this panel, you need to access to the right area of the aircraft. If it's in a complex area, you need to ensure that a human being can correctly access. These are 3D simulation, okay? And you access, you dismantle parts in order to be able to dismantle the final panel you want to change. And you bring a new panel and you install it, you assemble it. All these operations are movements in a real physical 3D environment. So this kind of service, my example of removal and replacement of a panel inside an aircraft, is a kind of service for which there would be a 3D model to develop the work sequence of dismantling and reinstalling, and also to store it and to use it. So all in all, when we are talking of digital twins, we are talking of the virtual reality of the product, the process, the production process, the manufacturing process, and the service in product life, and the physical product, the physical process, and the physical services. That is what we call digital twins. And some aircraft makers have today very ambitious projects in order to be able, in the second half of the present decade, to modify their way of developing products and use the digital twins. To a certain extent, if this goes real, we could imagine that we would have a little bit like an industrial system where intelligent, let's say, capabilities are a mirror image of human being, like using cloud and AI in a similar way as we use our brain, using IoT and sensors in a similar way as we are using our nerves, and using robot and automatization in a similar way as members. This is pure science fiction. I'm not saying this will be physically the case, but behind this use of digital capabilities, it's a little bit as we would decouple the power of the different machines in the industrial environment. Some key enablers to go to such an extent are first to start from an efficient industrial system, so to have gone through lean manufacturing before, otherwise you will digitalize useless operation. You will digitalize MUDAs, non-added value operations. Second, very key to clarify the company major business problematic. And business is never technical. Okay, business is relation to market. Do we need to be more agile? Do we need to have a reduced time to market? Do we need to reduce our costs? Do we need to have wide product personalization? This is a business reflection. It needs to be done to place the digital capability at the right area. Third point, the company will have to go through proof of concept. Impossible to develop upfront in the whole company. Another important point is that to move from the POC to the large-scale deployment, this will require specific competence of people that know how to define the calculation rules that are using the massive billions of data to show intelligence. If you don't have these people competence, and you only have data scientists, data analysts, you will not be able to drive any intelligence out from the data. Okay, so these experiences, people that have had the experience of the physical product, process, and services, that have had function experience, finance, program, engineering, quality, procurement, and that know how things are being worked, that know how things are in relation, these people have the ability to work with the data scientists, with the data analysts, and explain to them how it works so that these IT population guys can create the formulas that will use the data from the data lake and will show the intelligence. And last but not the least, very important, cybersecurity. We are logging a lot of data, but if companies are not protected, they will have tough times. Okay, and this is a real threat. So it's an important thing to address. Okay, small video to end this second session. Everything okay?
Yes.
Oh, sorry. It's probably. Are you still seeing the video?
No.
No, we are seeing your slide.
Yeah, there's an issue. Sorry.
No.
It's back. Is it okay?
Yes.
Okay, can you hear me back again?
Yes.
Okay, third part of this course, the sustainable factory. We'll try to accelerate a little bit to catch up on time. So first, that's probably a reminder for some of you, but now, hopefully, since, no, at least since 2 years, 1 or 2 years, the climate change is recognized by all stakeholders from most countries. And the origin is established with the causality relation between uh, human and the climate change. Okay, the climate change is started about 2 centuries ago in the 18th century around the Industrial Revolution, and now there's a common understanding that Anthropocene uh, is a major geological force in the meaning that mankind activity has an influence on the biosphere, which is probably the major one. The industrial company that has been built over the last decades and centuries on a never-ending growth model, consuming resources from a finite world, is and will be affected. We have been taught, maybe some of you, I hope less, have been taught that economy is consuming labor and capital. That's wrong. There's one thing missing. It's also consuming resources. And resources come from a finite world. Whether the resources is a mineral, whether it is energy, it comes from a finite volume that is our planet. So the company will be affected by this climate change, and this will come from various perspectives. It can be damages to the plants, to the different investments caused by some climate event. It can be reduction of natural resources that are key to operate. For example, there are many companies like in France, nuclear plants that are using cold water from the river for their operation. If the river level is down to a level that is not in line with their operation, they have a big issue. They might be affected by product disappearance. If temperature is continuing to increase, most of the ski stations will have to reinvent their business. And also, they can be affected by product disaffection. Air travel with COVID-19 is a typical example. Okay, air travel last month, well, in October most precisely, was still minus 71% of volume versus October 2019. Okay, this figure are revenue passenger kilometer is the unit used for air travel. In fact, when you look at this, it's not new. In 1972, a report was issued by a group of research people from the Massachusetts Institute of Technology. It was made upon a request from the ROA Club, which was a club of economical players that had questioned the MIT on what happened if we are never stopping to grow our consumption. And this led to a book, which I do recommend you read, which is The Limit of Growth. And one of the key writers is Meadows. And Meadows has designed curves by the 72 year that you have on the slide, which is well explaining what we are facing today. Okay, food per capita, service per capita, global population. This is the model that was developed by Meadows in his report. And the important thing to have in mind is that not that we are in 2020, we have records of what happened over the last 50 years. And the Meadows curve are the model which is the closest to the real figures of the last 50 years. So will the Meadows model correctly predict the coming years? We don't know. But throughout the different models, it is the one that gave the best prediction of the last 50 years. So it's definitely something to consider in our decision. According to the climate change expert group, today the different scenarios of temperature increase are between 1.5 and 4.3 in 80 years from now, depending on the evolution of greenhouse gas emission. All these experts are calling for all measures to support a 1.5 scenario. This image, I'm sorry, is not very easy to read, but this image is very interesting. It is extracted from a conference of the Shift project, a conference from Carbon 4, which is a consulting company for low carbon transition. And it shows the difference of, let's say, a landscape in Europe between minus 20,000 years and today. And you can see that the difference was huge. All the north of Europe and northeast, more precisely, was under big thickness of glass. Okay, all the Eastern Europe was very cold and dry. And this situation, only 20,000 years ago, was having only 5% temperature, 5-degree temperature difference with today. So this is illustrating how a change of 5 degrees is affecting the natural ecosystem, the climate of our world. With this upheaval and the current Earth path, which is according to 3.2 scenario and not 1.5, there are growing actors calling for strong measures. Political actors, citizen organization, and more companies coming to it. Europe, end of last year, has started to work on Green Deal with strong measure calling for CO2 transitions. And very recently, Europe has voted an increase in the ambition with minus 55% target reduction in 10 years' time. It's not on the slide. Recently this year, Europe has finalized a budget for this Green Deal with 750 billion euro plan targeting to reduce the carbon emission, the greenhouse gas emission for many sectors. And why it is important that companies and countries are pushing for that is because what we can do ourselves as single citizen is only addressing a quarter of the need of reduction. This is well illustrated on this graph. You can see that it's in French for the non-French speakers, but your French speaker friends will translate, I'm sure. So this is what we can, what is realistic to address with only individual behavior change, okay? And this is requiring society systematic transformation, because behind this reduction to reach the Paris Agreement target, we have the way we drive agriculture, we have the way we drive industry, we have the way we drive mobility. So this requires change of companies. For those who want to learn more, I do recommend to involve yourself in understanding what comes out of the Shift project, which is an organization pushing for a transformation of the French economy. and targeting to push this plan at Europe level once France has understood this plan. And things are moving. I start to be optimistic thanks to COVID-19. It's incredible to say that, but believe me, thanks to COVID-19, the acceleration of understanding of some political leaders and some companies in France is 10 times more than it has never been. Also, we have non-governmental organizations that are getting an increasing power. The example on this slide is about Carbon Disclosure Project, named as CDP. What is CDP? CDP is an NGO organization, international one, pushing human organizations, companies, countries, cities, to first communicate their greenhouse gas emission, their water consumption, their forest impact, to communicate it to their database. Second, once this is communicated to the database, the CDP organization is pushing the human organization to work on targets in order to reach the Paris Agreement by 2050. And they push to set up these targets with a science-based approach. We will have a video explaining what it is. And once this is done by the human organization, this NGO is pushing to communicate publicly. Means that any human organization, think Total, Boeing, Toyota, any human organization having communicated its data, its target, its work plan with a science-based approach to this CDP, in the last stage, this company will be pushed to open publicly to anybody, you, me, anyone, to access to this data. And why the company will push for that? Because there will be, and there is, a strong push from the financial institution. More and more banks are increasing the pressure on company to join such initiative. This means that in some years' time, if the companies are not on board such organization, bank will start to withdraw from this company. Bank will start to stop fundings. So that's a very positive trend. Back to aviation. You have on this slide the growth between 1977 and 2037. So you can see that every 15 years, we are doubling. This is a result of the 5% yearly growth of aerospace. And this is explaining why today air travel has an impact of 2.5%, a contribution of 2.5% of greenhouse gas emissions. If we are having this growth over this 80 years, you can be sure that in 2100 year, aviation will not be 2.5%. It will be much, much more. It is not new for aerospace to reduce the consumption of kerosene, of energy to fly an aircraft. You have here on this slide the evolution of the performance, okay, per passenger for 1,000 kilometers. So it's similar data as RPK between 1920 and 2020. So you can see that it has been very well improved, approximately divided by 10, okay? Maybe similar to the cars, by the way, I don't know. And this has been done through the use of improved materials, lighter materials. First came aluminum, comparison to wood, not that much lighter, but much stiffer, so requiring less volume. Then we introduced composites. It has been made possible also through improved engines. And it has been made also possible through the optimization of aircraft use. Means aircraft are much more filled with reduced empty seats than before. I'm not talking of the present year with COVID, of course. Yet, this is not enough with the target of the Paris Agreement. And there is a growing public opinion, there is a growing governmental pressure on air travel, and it has been accelerated with COVID-19, so that aviation sector is addressing this issue in a more efficient manner. You can see also here that the different levels for reduction has enabled, or will enable, sorry, has enabled, yes, the aerospace industry to increase the air travel without just an increase of airplane. Actually, the airplane increase is, I would say, is going with half of the increase of air travel, and half of the increase of air travel has been addressed with better utilization of aircraft. Why do we need to consider this issue in a more efficient manner in aviation sector? This chart is very interesting. It's been released a year ago by the financial analyst of aerospace industry at UBS. It's a woman that made a very interesting report and presented it in a conference in Toulouse a year ago. And she has been studying the UK household behavior. This is in 1990, and you can see that at that time, the aviation sector was only contributing for 4% of the average greenhouse gas emission of an average UK household. In 2017, the 4% was up to 12%. So you could tell me, but how come? You just told us 2.5%. Yes, 2.5% is worldwide. Do you think the average African, do you think the average Filipinian in our world is using as much aerospace for the consumption product, for the food, for the leisure, for the vacation as you do? Definitely not. So this average 2.5% is fairly higher when you are in the European countries. 4% in 1990, 12% in 2017. And what will be the scenarios in 2050, the year of the Paris Agreement target? The scenario, depending, we will be having, I would say, a very efficient scenario or a core scenario or I would say in between one. In the three different scenarios of CO2 emission by 2050, look at the place of aviation. In two, it is the first segment of greenhouse gas emission of the UK household. In the third scenario, it's the second bigger. Do you think the UK household will accept to live in a society where aviation is becoming the first contributor of CO2 emissions? No way, no way. So Europe citizens will push more and more, because UK are typically representative from Europe households. So they will push more and more the aviation industry to change and to develop alternative way in order to reduce their GHG emissions. How? You see on this slide, by the way, that if you compare with the other sectors, aviation is probably the only sector that has still an increase in the emission among the other ones. So how we will come to that? it will require new generation of solution. New generation, it will require, to generate new solution both for the propulsion and for the design and the manufacture of the aircraft. Okay? At this stage, we are doubtful, I am doubtful about CO2 neutrality. Some actors are talking of zero emission aircraft. I consider that at that moment, it is pure marketing. It's fine. It's good for marketing because it's pushing for that. It's pushing us to go to the lowest possible. Many company, my company, for example, is always communicating on a zero accident. We are 7,000 employees. Last month, for the 11 first months of the year, there was 28 injuries recorded in the company worldwide. Okay? We are talking of zero accident, zero injury policy since 10 years time. Okay? And we are a leading company in the area of safety. If I am climbing a stairs or in my office without taking la rampe, sorry, I don't have the English word. The ramps, thank you. If I'm doing that and my CEO sees me, you can be sure I will get a blame, an oral one, a verbal one, but I will not do it twice. Okay, so I have no issues with Airbus talking of zero emission aircraft. I'm just saying that from an engineering standpoint, from a scientific standpoint, I'm very doubtful, and engineers and scientific are doubtful that aviation can be neutral with CO2 in 2050. Never mind, it's a target, and we need to drastically reduce that and find solution for drastically reducing the emissions. Okay, and you can see here that the different scenarios with the potential of technology improvement, the potentials in operations of aircraft improvement, the potentials in alternative fuels, the potentials with traffic moderation, we need all of them to reduce by 3/4 the impact of air travel. And believe me that up to today, understanding and accepting and communicating within the aerospace industry, within the aviation market, communicating that we need to moderate the consumption level, the market level, this is not yet accepted because it's very difficult, because it means monitoring a market with the opposite of growth. And that's not easy. We have not studied that. We are not prepared to that. So we will have to come to it, but it will take time and evolutions. What are the technical levers to reduce? Biofuel, traffic optimization, and propulsion like electric or other like hydrogen. What we do need to use to drive this improvement, we need first to accelerate in the utilization of a powerful tool which is called life cycle analysis, LCA. In French, analyse du cycle de vie, or ACV. It enables to measure end-to-end the impact of the different players, from the early suppliers that are producing the materials, that are digging the ground of our planet to take minerals, transform them in materials, down to the end players that will retreat, disassemble the part of an aircraft after its end use, and will do something with the final parts. And in between, you have the air travel, the 20, 30, 40 years of an aircraft in utilization, the MRO services, etc. We need to perform this LCA from an end-to-end standpoint with all the contributors. So it's not easy, because it means we will have to suppliers, the customers, the MROs, the airports, the airlines, all together to make this end-to-end measure and to agree on what is prior, what makes sense. Do we need to pollute with the production of material from the composite industry? Because in the end, we save much more during the aircraft utilization instead of reducing composites manufacturing and increasing aluminum manufacturing? Of course, my company would say the first alternative. But it's impossible to know if we are not working all together. And to work all together is not enough. We also need to have the same measure, the same units, so that the LCA conclusion of Hexcel can communicate with the LCA conclusion of Boeing, Airbus, and Embraer, and that of Air France, Emirates, Lufthansa, and whatever. We are pushing for ambitious programs. I will display to you 2 short videos that show first a research program on biological fiber that Airbus is having with AM Silk, which is a company. Will this come to reality? Frankly speaking, I don't know. It's a research program, among others. It's interesting to know that there are such programs. And I will also display a short video on the Zero-E aircraft that was released 2 months ago by Airbus. Okay, so as I said, companies are coming to sustainability, and this move is not disconnected from COVID-19. You have here a collective panel signed by 100 CEO of French and international companies in May this year. So I'm pretty positive in the way our society and our industrial world is accelerating. I will not display this video because the audio is not visible, but you can easily upload it in or visualize it in YouTube if you want. This is explaining the science-based target. Science-based target is a methodology to define the greenhouse gas emission targets for a human organization. It's a methodology that use the, I would say, remaining volume of CO2 that we can generate if we want to be in line with the Paris Agreement. So it is starting by the end. It is considering that in order to be where we want in 2050, that is the maximum volume of CO2 that we are allowed to emit. It is then taking this global volume and splitting up by sectors, by companies, by areas. So in the end, any human organization is having a credit. And if this organization wants to contribute to the equal reduction portion of the CO2, this company needs to generate not more than this credit. That is what they call science-based approach. So it's very powerful. It is taking the human organization as adult, mature entities that know what they have, each and every of them, to commit to, so that all of us will be at the target in 2050. So don't hesitate to look at this video if you want to know more on it. Okay, that's the end of my lesson, the third course. Now, as said, we will have a break. In order to be on time, I would like that we don't take more than 5 minutes. So if you can be back at 9:56, and we will have the case study presentation, and we will all work on this case study. Okay for that?
Yes.
Okay.
Yes.
So first question, have you received the document for the case study?
Yes, we did.
Yeah.
So can you confirm that you have 2 PowerPoint document and 5 Excel file?
Yes, that's it.
Okay, super. So first I will present the case study. Then we will have about 1 hour of preparation per group. There will be 5 groups, and we will complete the session with half an hour presentation, 5 minutes per group of the solution that was defined by each group. Okay?
Yes.
Sorry. Can you see my slide? Maybe not.
Yes.
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 Okay. So first I will take about 10 to 15 minutes to oh, sorry. Apologies. I will take 10 to 15 minutes to explain the case study, and then we will move to the hour preparation per group. Okay, so the case study is after aviation ecosystem, as you can imagine. We consider that aviation ecosystem is all the private and public entities that contribute to the activity, the aviation. And they are contributing through development, manufacture, delivery, operation of infrastructure, product, and services, and through the definition of the regulation that offers the proper frame for the exercise of air travel in a safe way, in a sustainable way, in an economical acceptable model. This ecosystem is shaped by several market aspirations. Among those aspirations, we have environmental topics, we have quality topics, we have cost, financial aspiration, We have lead times. You don't expect to spend 12 hours if you take Air France to fly from Toulouse to Paris. And we have social aspiration. Meeting those market aspirations require to consider some business aspects, some business imperatives for the different actors of the aviation ecosystem. These imperatives are very diverse. I have limited our case studies to 15 of those imperatives, but each imperative is primarily connected to environmental, quality, cost, delivery, or social aspiration. If I take an example, in the environmental, sustainable, and governance aspiration, we have the Paris Agreement targets. So reducing our CO2 footprint by 3/4 in 30 years' time. Another example on quality, top class quality company are trying to target less than 10 non-confirmed parts over 1 million of parts delivered. This is the norm since 20 years in the car industry, for information, between a supplier and a customer. We are not yet to that point in the aviation. In aviation, this year target in the commodity of material and parts, which is the commodity where my company is acting as a supplier to Airbus, the Airbus target was to be under 200 ppm. 5 years ago, the target of Airbus was to be under 2000 ppm. So we are coming to it. So it's acceptable to say in 30 years' time, less than 10 ppm. If I consider cost, one target can be to have operating cost of an aircraft that is fairly reduced in comparison to today. About delivery, we could look at one aspect in relation with the final customer, any one of us, that would consist in targeting to be less than 2 hours between departure time of your place, let's suppose it's your home, and flight takeoff. Is what I call home to flight lead time. Less than 2 hours in a big metropolitan city in Europe. Social aspiration to enable anybody to fly, whatever its social class. We will consider one country, a fictive one. I named it Europe Kingdom, EUK. You can think whatever it is. Will it be the integration of all European countries? I personally hope that we will integrate Europe. Will it be one country? I don't care. It's a fictive country. And in this country, aviation ecosystem has set itself the targets in 2035, in 15 years' time, to set up an affordable, safe, and sustainable market for passenger short-haul air travel. So less than 1,000 kilometers in EUK, so it's not an international flight, it's a national flight. And the volume expected for this market is to be able to fly 800 passengers per week. We will represent the aviation ecosystem with 5 entities. One airline that we will call AirDream, one airport that we will call Queen Elizabeth Airport, one NGO organization having voting rights at the EU Parliament that we will call GDCP, one aircraft manufacturers that we will call Aerotech, and one aircraft parts supplier to the aircraft maker that we will call FPC, for Fly Part Company. In order to meet the goal in 2035, the 5 actors are responsible to produce a deliverable to the aviation ecosystem. So we will have 5 groups in the case study. You will be, all of you, in one group, and each group will represent one actor. We'll have a group for iDream, a group for QE Airports, one for GDCP, one for Aerotech, and one for FPC. And each group will be having the responsibility to elaborate a deliverable and to present it at the end of the session. How we organize the work after the presentation? You will have an hour work in group. And after the 1 hour group, we will have 25-minute presentation, 5 minutes per group. For the preparation, I will move from one group to the other using the breakout function from Zoom. So I will automatically create the groups. It will be a random definition. And each of you will be in a group of 4, 5, or 6 persons. You will first read and understand the document. The document includes this one, a PowerPoint document that is just a template for your presentation, so you don't waste time in creating PowerPoint documents. You will just have to type to upload a table in this 6-page document PowerPoint. And you will have one Excel file, the one corresponding to your group. Okay? So the 4 other Excel files, you don't need them. In the Excel file, you have 2 sheets. One sheet is your sheet. You can do whatever you want. You can modify, you can type, you can copy paste. The other sheet is protected, and the other sheet is the consolidation of all actors. So would you want to understand, if you are in Adrian group, what QE Airport is having in terms of deliverable parameters? You can look in this big Excel sheet, but it is not necessarily needed. I will explain. So first, you will read and understand this Excel sheet, and if needed, you will reread this PowerPoint. Second, you will design minimum 4 roles. You need to have a leader. It will be the one who will present the 6-page PowerPoint by the 5-minute session. Second, you will need a spokesperson. The spokesperson will be the person talking to me when I will move from one group to another in order to take your question, ask them to the proper group, get the group answer, and feedback to you its answers, okay? Because you are an ecosystem. So you cannot decide whatever you want independently from the other actors. Your decision need to consider the other actor decisions, because in some case, their decisions are reducing your possibilities, okay? So the spokesman will be talking to me when I will pop up in your session, and will let me know what you want me to raise in terms of question to which other group. Third, you will need to assign the role of a writer that will be in charge to create the PowerPoint. Actually, I said 6 pages, but there's a front page, so it's only 5 pages, sorry. And last but not the least, you will assign the role of a timekeeper, because time will fly. You have an hour, and you need to stick. You need to do the presentation in time. And in any case, I will limit the time of the breakout function. So by the end of the hour, the group will be stopped, and you will be presenting each one after the other. Third, after these roles are defined, you will start working first on your deliverable. So you will elaborate the global design. That is to say, not the possible that, for example, you are AirTech, you have decided to use composite material for your aircraft, and in the end, you understand that because of some constraint coming from the NGO organization, you cannot use composite. Okay, so you have to modify your solution to integrate the decision of the other groups. You will finalize this work of your solution, and you will finalize it with the design thinking approach. So you will start to think, okay, is my solution desirable from social perspective? Is my solution feasible from technical perspective? And is my solution viable from business perspective? And finally, you will complete the 5-page document. The writer will have started to do in parallel, so that you have your document prepared for the presentation. I will cut the preparation session, and we will all be back in the plenary session, and we will do the presentation with the alphabetic order. So the order will be Aerotech will be the first group to present. Then we will have AirDream. Then we will have Flypart Company. Then we will have GDCP. And finally, we will have Queen Elizabeth Airport. For the presentation, you will have 1 minute to show the slide that describe your solution. I suggest that for this slide, you make a copy-paste of the final Excel file that you have decided. In Excel, you will have closed answers. Okay, I come to it. So you can just copy the final choice. The second page, you will type a few assumptions that you make. Why you will make assumption is because first it's a prototype, so there are mistakes, errors. There will be things you don't understand because it's complex. So you will take assumption. There's no bad assumption. It will be yours. And in the last 3 slides, you will give the main arguments of why you consider your solution is desirable, why you consider your solution is technically feasible, why you consider your solution is viable from business standpoint. The deliverable that you will work out must take into account the business imperatives you may imagine. Okay, those imperatives do not apply evenly to all actors. Some imperatives are common to several actors, some are specific to some actors, and some imperatives are primary, others are secondary. You have on this table the different imperatives, and for each group, if it's a primary or a secondary one. In the design of your solution, you will have to consider the primary imperative as mandatory. You cannot present a solution that goes against the primary imperatives. But the secondary imperatives, they are optional. So you may decide to consider them or not. You may decide to go for a solution that goes against it or in favor of it. Of course, the more you will go in favor of the secondary business imperative, the better your solution will be in terms of desirability, feasibility, and viability. This is a summary, the 5 groups: AirDream, QE Airport, GDCP, AirTech, FPC. This is their primary business imperatives, so the major one, the one that are mandatory for you to consider. And this is the deliverable presented by the subgroup. I will go very quickly because in any case I will come to your session and one I can do explanation. Citizen social class fly, and will deliver the passenger pricing model. So on what objects they will define the air travel price, and also we'll give some things around associated passenger service. QE Airport will have to meet less than 2 hours from home to flight, and we'll present the passenger mobility solution, so how the passenger goes from his home to the takeoff, not the airport entry, the takeoff, and also what are the ground services for aircraft offered in the airport. GDCP must consider the Paris Agreement, and will have to propose a set of new regulation. AirTech will have to reduce the operating cost of the aircraft and will present the architecture solution for the next generation aircraft, propulsion and airframe. And FPC will have to care for top quality parts, less than 10 ppm non-confirmed parts, and a reduced lead time end-to-end between the raw material and the final parts produced. And FPC will present the material choice they have decided, and the supply chain architecture. This is a summary table. Don't go in detail reading. Just consider that you have the deliverable here in line for the 5 groups. Each deliverable is the result of some contributors. A contributor, for example, is the aircraft. AC stands for aircraft, propelling technology and energy. Another example of contributor is the aircraft part material. So there are several contributors. They contribute to your deliverable. If I take the example of AirTech, how you will elaborate your deliverable will be as follows. For AirTech actor, these contributors are influencing its deliverable, which is the architecture solution, through the parameters. So in fact, your work will be after choosing parameters. Example, in regards to aircraft propelling technology and energy, AirTech has to choose a technology where the readiness is in line with the timeline. AirTech cannot choose a technology that will be ready in 2050. It needs to be ready for 2035. Another example, on the aircraft part material, AirTech will have to choose the energy saving than they target based on this choice of material. Means when AirTech knows that wood or whatever, AirTech will set its target. I want to reduce the energy consumption of minus 20% also. So AirTech will work on this parameter. It will choose some parameter among a frozen list of values. This is the example with AirDream this time. So in the case of AirDream, you have, for example, a parameter which is the energy cost. And you have 3 choices. Electricity, 15 cents per kilowatt hour. Petrol, kerosene, 16 cents per kilowatt hour. And liquid hydrogen, 5 cents per kilowatt hour. Okay, so the group will just decide 15 cents, 16 cents, or 5 cents. They decide for the cost, they don't choose the energy, they choose the target of the cost of energy. They will also choose the flight time. So their choice will be 2 hours or 1 hour 20. Of course, the choice of time is related with the aircraft type. But if they choose 1 hour 20, AirTech can choose to go with a twin lane or a single lane. Of course, if they choose 2 hours, the choice of the aircraft is implicit. So, in the parameter list that contribute to the deliverable of each group, not all parameters either it is a parameter that is not common, so you're the only one to decide, or it is a common one, but it is your decision. Three, sometimes you have up to 6 choices. Okay? You prepare using the case study presentation that I have displayed now, you have it, using the Excel sheet that you have corresponding to your group, and you prepare with the 5 pages PowerPoint. You only type in the yellow areas to customize your version, and you will use it to present. Is this globally understood? And I can move to the group session.
Yes.
Yes.
I'm sure you have not all understand, you have not all understood, but I will explain deeper when moving to the groups.
Okay.
Okay?
Okay.
I will now split. I might take 1 or 2 minutes to create the name of the groups with the breakout function. And one last question: how tight are you by 11:30? Just for me to integrate the constraint.
It's just our lunch break, and then we will start again at 1 p.m.
At 1 p.m. So I need to have your guidance versus a choice. I spent more than I need, well, more than I should have spent for explanation. So we have two choices. Either we reduce the preparation down to 45 minutes, it might be tough, or we extend the session from, I guess, 15 to 20 minutes. What do you prefer?
Mm. Mm.
I think I'm fine to extend. It looks interesting to listen to everybody's solutions, and yeah, I think it was a lot of preparation also. So let's go through with it to the end.
Okay, thanks. I do appreciate. I just need to find my box for
of innovation. And yeah, that's right. Let's go next. And after, what can I say? If someone in my team want to share something, we can. We can. And after, so I think it's, oh yeah, yes, the big choice was in the industrial way, because we try to reduce costs as much as possible. So we choose to be just in time for the delivery and the stock. And on the geographic location co-localized.
Does it mean that you intend to set up all your plants in Europe so
Yeah.
that they are close to each other?
Yeah.
Yes.
Right.
Okay.
So we will reduce costs about the shipping, about the manufacturing, etc.
Okay.
And it's also eco-friendly.
Okay. And you have chosen the plug-and-fly cabin system, so that's very innovative, interesting. Though you have chosen aluminum instead of composite, so you are ready to consume 20% more energy to propel your aircraft. What's the rationale behind this?
It was choices by the other group, so then to stay relevant as a flight part company have chosen aluminum based. Then we thought it was more relevant to choose aluminum and petrol.
Okay, that's
And
right.
all our yellow cells are the choices from other group that we just
Okay.
added.
Okay, I understand. So good. You're right. You respect the choice of the decision of material was in the hand of FPC. Nevertheless, it's important to know that when you do an end-to-end life cycle assessment of aircraft, one big figures that come out of that, it's not me saying that, it's Jean-Brice Dumont, the engineering vice president of Airbus, in discussion at La Tribune by November 16 this year. 5% of the greenhouse gas emissions are produced at the manufacturing stage of the aircraft, and 95% are produced during the aircraft 30 years use in operation. So it's important to have that in mind, that maybe saving CO2 emission when manufacturing will create opposite effect when the entire life cycle of the aircraft is considered. But good, it's interesting. Okay, can you give a few words on your design thinking element, if you have?
Not this one. Right after. About design, for example. Yeah.
Yeah, move to the design thinking. Okay.
Yeah. We are in the part of design thinking.
Yeah. Okay. Can you quickly present?
Yeah, of course. But as you can see, our choice was to be the less costly for customers and more eco-friendly by the hydrogen and the size of the aircraft.
And also the way that the manufacturing is done.
Yeah.
Okay.
Right.
Okay, good.
And yeah. About the feasibility, I would not talk much because we don't have time to do it.
Okay.
Yes, as we say, we just the hydrogen power. It's quite new, so we don't know if it's going to be
Not so
feasible
new.
in
It's
the.
not so new. It is used in space since many, many years.
Yeah,
It's used as a propelling energy today, so it's not new. The difficult point is to develop green energy of hydrogen, because hydrogen is existing today, but it's definitely not new. So it is requiring a lot of energy to be produced, this hydrogen, and the emission of CO2 is made to produce hydrogen. Today, when you produce kerosene, you don't emit. You collect petrol from the ground,
yeah, that's right.
very little emissions. So the challenge is here to develop green hydrogen for you to keep in mind. Okay, next.
Okay, thank you. And the next one is the viability. Maybe someone else want to speak about it.
I can speak about it.
Yeah.
We thought about several points, and we took into account also the end user point of view. We haven't made enormous changes on the aircraft side. We thought about the fact that passengers could just stand during the flight, but actually maybe they are not ready for this kind of disruptive change. Also, the main objective of every company is to make some returns on investments. And those models are already proven, they work. So maybe in a few years they will be still valid. And also we saw that there is a new trend on the transportation, on the transport means. So the trains, buses, etc. are very slow, and maybe a flight would aircraft will be just the future of current travels. And finally, the customers and also the companies are under the pressure of the environmental issues. The companies have to stick to the RSC objectives of the company and also to the European laws. Okay. And the customers are more and more aware about the climate change. So yeah, maybe what we have proposed is the best thing for the environment and for the company.
Okay, thank you. So second group, AirDream. In order not to spend too much time, when you present the solution, please just mention the choice. Don't give explanation or arguments, and keep those when you present your assumption and design thinking.
Yes, just 2 minutes. I will.
Good work, AirTech.
Yes.
Well understood.
Thank you.
Not an easy job.
Thank you.
Up. Sorry. Can you see my screen? Yeah.
Yes.
So I will go. So we are AirDream, one of the best airline in the UK. Up, and to stay competitive, we will. So yeah, quickly. So to go quickly. So yeah, we choose hydrogen energy for regional navigation with 50 packs, 2 doors, and a flight frequency of 3 flights per day. Here you can see more of our choice. For desirability, first our 2 main goals is to reduce by 75% CO2 emission by 2050, and also enabling all citizens social classes to fly. So the first, with 3 flights per day, it's to address a large customer and people to take our flights. Then we choose hydrogen propellant to have a low impact on the environment and continue to be a very innovative airline. Low-cost flights also for regional and for citizens, that with turnaround of 3 flights and 50 packs, we will try to reduce our costs. And also with, for example, just 2 doors and a very simple, simpler aircraft, we will try to have less risk for our operation cost.
Okay.
Feasibility, yes, we try to the less expensive R&D choices, even if we will try to match with hydrogen propulsion. Again, with logistic 2 generators and try to be very quick for loading and unloading. And for viability, we will match, for example, for a week, it's more than 1,000 packs, and the goal was 800. So it's more or less a load factor of a week of 54%. Nevertheless, we foresee that to reach this number, we will need some incentives to reach 100% of load factors, and also to keep the pace of 3 flights per day. We will need to have a very good OR to ensure efficient turnaround time.
Good. Okay, thanks. Very good presentation. Do you know the real difference of fuel consumption, kerosene, between an A320 and an ATR 72? I could take a 737 and a Bombardier Q400, for example. The difference is 35%. So if you go, for example, if you are an Airbus employee and you take the internal flight that Airbus has between the Airbus Toulouse plant and the Airbus Nantes plant, it will take about 1 hour. It's about 1 hour 20 minutes, 1 hour 10 minutes to reach Nantes with the ATR. It's a propeller, so it's a regional flight with a propelling turboprop system and kerosene. If you take the same route, if you go on the same route between Toulouse Airport and Nantes Airport using an A320, your flight will be about 45-50 minutes instead of 1 hour 15, 1 hour 20. So probably 40% less time, but you will consume 50% more kerosene. Okay? This is available. This is today technology. And none of us, me the first, have realized that over the last 30 years, to save 40 minutes on the Paris to Toulouse, we have set up Aerospace air travel system with only turbofan. Is it the right decision? Do we need to reach Paris in 1 hour 5 minutes for Orly instead of 1 hour 50 minutes? I raise the question. I don't have the answer, but I'm definitely sure your generation will have to solve such kind of questions. In some case, for some services, definitely yes. Safety services, armies, yes. Each and every of us, not sure. That's my personal view. Okay, next group. Which one is FVC, Flypad Company? So the benchmark worldwide supplier of aircraft parts that has win the business of making all the airframe components of this new regional aircraft. Do we have the CEO in the room to present its solution?
We are here now. Amanda, could you share the? Perfect. Thank you.
Amanda is the CEO. I would wish we have.
We are all CEO.
I would wish we have a lady as a CEO. Too many men in aerospace world. Okay, good. Listening to you.
Could you make the other tab, please? Thank you. So we choose, as you could see, our choose. Next slide, please. So we choose aluminium because it's the most common used now, and it's the fastest material to use in material environment sustainability thermoplastic composites in development for the future. Manufacturing costs automatic in EU to use less distance with our customers and for working. AC development thermoplastic composites manufacturing time, so the shortest one, because the main thing for us was to be as fast as possible. If you have something to add, guys, I'll let you.
Just one question. I don't completely understand your double choice of aluminum and thermoplastic composite. Do you mean that today you design with aluminum?
Exactly, yes.
And for the to upgrade your aircraft with thermoplastic parts instead?
Yes, exactly. Because right now we need to be fast, so we use aluminum. And when it's gonna be, sorry, I have some issues with my.
Okay.
Could you?
Oh, I thought it was at my place. There was an alarm bell, but go ahead.
Yeah, yes, it's on my it's my apartment, so I have to. Guys, could you take my place just for a few seconds? I have a little issue.
Okay, well done. Thanks. Interesting choice of double solution, short and long term. Okay, can you move to the design thinking argument? Okay, let's give a.
Yes, so for the desirability part, well, because of our two main factors and the choices we made, the products will be available on the market very fast because of the choice of aluminium. And also it's going to be high quality, so less than 10 faulty products per million parts. And also we decided to make production local in Europe in order to reduce the time to market. So we're encouraging the local economy. So this is also a strong factor in the desirability of our product. And lastly, because the production is local, we don't have to pollute for transportation between continents. So it's less polluting, and also it's reducing the time to manufacture the parts. So this makes the product more desirable.
Okay.
Yeah. Then for feasibility, yeah, aluminum was the most relevant product to choose in order to have a short time to market. So we believe that this will enable our plan to be successful. Also, the fact that the manufacturing lead time is short, so because everything is localized, so this will make this will also be a factor in the feasibility of our plan. This will make the time to market very short. So these are all factors that make it successful.
Okay.
I know what else to say for feasibility, and for viability. We thought that the fact that because a part of aluminium is recyclable, it will make that we will have less losses, and we can reuse some part of the aluminium that has been used for production. So this will make it more viable. Also aluminium lasts more in time. So, yeah.
Okay, good. Very quickly, if you comment, good idea to think of introducing two solutions one that can be fast on the market. We usually forget that time is key, and when you work on a super solution, but the solution takes 10 years time before being introduced, it means that the renewal of the market will be very much longer. Okay, when everybody says zero emission aircraft in 2035, okay, let's assume we succeed. It will be the first aircraft in operation. But before we have replaced the 20,000 aircraft that are flying in the world, it will take additional time. So going fast to the market is very interesting point. Second, for your information, thermoplastic of long composite is under research and technology project today. There are ambitious projects, notably in France, with ICOPAS. Charles knows because we discussed HAICOPAS, which is a research program in France gathering automotive, energy, and aerospace after the development of structural long fiber composite thermoplastic. And one, among other interests in such a program, is to develop recyclable composites, because the thermoplastic resin is like the water, whereas thermoset composites are like the egg. When you eat the egg, once it's cooked, you can't melt it if you reduce the temperature. With the thermoplastic, which is like water, if you go the temperature up and down, the plastic melts and you can reuse it. So that's one interest of potential use of thermoplastic composite in the future. I'm not saying it's done, but it's one of the reasons why we are developing. Okay, next group, GDCP. Thanks again, very good presentation.
I'm not sure if you can share this, how you see the screen.
Yeah.
Yeah, so
So you are the GDCP leader? I don't hear you anymore.
sorry, I've been having internet issues. So I'll just quickly run through. So the team was made of Faustine, Julien, Sebastian, and Valentin, along with me. So these were the decisions that we made across. So just running through the individual decisions, we were supporting the local MRO and parts reuse. Definitely subsidizing for the development, and in terms of mobility, we did try to slash the CO2 emissions and encourage the H2F program. In terms of local manufacturing, we try to introduce trade laws which provided incentives for local manufacturing, and definitely if more substances were used and there were bans on highly critical items which contribute to CO2, because that was the primary initiative for us. In terms of assumptions, the key was to definitely reduce CO2 emissions. Just try to make the most of the impact starting from 2025. And people are often seduced by the eco-friendly actors, especially during a lecture. You said that like digitally they produce more waste than in the aerospace sector. So we tried to tackle that aspect as much as possible. And we also assumed that the technology is mature enough to support all the changes that we have assumed. The regulation of aircraft usage was already in place, and taxing the worst case scenarios and promoting local activities was other assumptions. In case of desirability, definitely again reduction of CO2 emissions, both in the entire value chain was most very critical for us. It's more, we also try to have more convenience for passengers, which with the public transport promotion. Restriction of H2O mobility with constraints. This is more applicable to programs which involve diesel or other aspects like higher CO2 emissions vehicles or programs. Also introduction of taxes into air premises. In terms of feasibility, the vision of 2050 should be executed in stages. On the second point, we were a bit critical, as I said, that people are often drawn by the sustainability term, and also especially these days where air bashing and aircraft banning is very much in high. We decided that the high-speed train should be encouraged in case the CO2 emission reductions were not met during the initial phases of implementation, especially depending on the other players in the value chain, the stakeholders, like the manufacturing part, the part manufacturers, the aircraft actors, etc. In terms of viability, more regulations on emissions will force the companies to lead to innovation, which creates new job. Also supported by the state subsidies, because we thought that like everyone went ahead with the local manufacturing options. And unavoidable taxes fund the free S2 program that we created, because one of the players went with the cost, but we decided to make the S2F program free for the passengers if it was green enough. So this is pretty much from our end.
Okay, very well. Thanks. Good summary. Okay, last group, QE Airport.
Yes, hello, sorry, can you hear me?
Yes.
Okay, so we are the Queen Elizabeth Airport, and we are doing this airport. So these are the solution description we chose. So we were to go for an electric propulsion system, but because of the manufacturer constraints, we had to go for the regional hydrogen turboprop, which is a low, which provides low noise frequencies. So we chose a one-axis bridge, parallel operation, so one pod team for all aircraft services. This will allow flexibility between the working force in order to get quicker services. We chose to focus only on maintenance for engines, so that we could provide less noise emissions from our aircrafts. As for the mobility solution, we considered a fast direct underground, and thanks to the social incentives that were presented earlier, we are able to provide these services for free for our passengers. So we chose the fast direct underground service. We chose for the airport services automatic service. This will allow also digitalization of our airport, which will provide new business models. And we chose as per the last groups, we are in accord to go with the plug and fly cabin, which will also allow quicker operations, and a classic horizontal storage with 200 operational destinations offer and fast direct underground. So moving on to the next slide. Some of the assumptions we took is first of all, the distance between the airport and city center. We took it as 20 kilometers. So this will be an $8 trip from the city center to the airport, and an 8-minute trip, so it's pretty fast. We did not consider we could have a high impact on CO2 emissions, because this was not our main concern. It was our secondary concern. So we focused mainly on the accessibility and on our noise emissions. And we also assumed that the airport is willing to undergo changes in infrastructures, which could lead to some operational problems. So for design thinking, for desirability, we want quick transportation to airports. So from home to flight. We want to reduce noise as much as possible for people nearby, and for passenger satisfaction, airline satisfactions, and for the social impact, so the neighbors' urban footprint. and we want 100% accessibility to every social class. That's why, with the accordance of the other group, we provide the. As for feasibility, we have to consider different things. First of all, we need to consider implementing the right technologies for our quality management and our maintenance. So if it's possible, respect the time constraints for the flights and the frequencies, respect the government legislation, integrate the previous technology with the new ones, continuous improvements of our services is important also to keep on growing. And a geological analysis for the underground is important in order to build our network, our underground network.
Mm-hmm.
Finally, for the viability, what we focused on is meeting the customer price expectations. So we want a efficient but also a financial viable option. And the customer quality expectations, this is mainly for our airlines. So they want to come to an airport that is accessible. And yes, so using digitalization, we could reorient our business strategy. Then our solution is dependent on the technical feasibility of both manufacturers, and airliners. So this is important to take into consideration. And we want to respect the profit constraints in order to be a profitable organization and applying good supply management. So
very interesting. Good, good. One comment on hydrogen. What makes you, one question, what makes you sure that your solution is independent from the feasibility of hydrogen?
In which part? In the first part here?
How will you refuel aircraft with hydrogen at the airports?
Well,
remember, it's an energy that needs to be at minus 250
This is true. This is true. This is a big issue, but we are considering implementing refueling systems. So that would also help from the production of hydrogen. So either through electrolysis or through steam.
Will you favorize production of hydrogen inside the airport, or will you have the production elsewhere and transport it in tanks to the airport?
I think due to environmental reasons and for the population's acceptance, it would be better to have them transported from plants towards our airport.
Good.
Because having power plants in the airport could lead to some social and also economical
Good. So you are in the same mindset as the former CTO of Airbus Group. I don't have his name in head. This guy was at Airbus between 2013 or so and 2018. And he left and he founded a company that is developing a technical and logistics solution to provide hydrogen bottle to mobility companies to set up the future system of refueling. So it wouldn't be refueled directly with the liquid energy, but refuel by the replacement of filled bottles that are filled elsewhere in the manufacturing plants.
Yes, probably also an underground cable infrastructure could be put in place, but that's also another concern.
Okay, thanks a lot to you. Very good presentation as well. You all did fantastic presentation. Thanks a lot. I'm amazed how you were able to understand my prototype case study. I hope you enjoyed. It's very late. You have only 30 minutes for lunch. So I'm not expecting you to stay. If some of you wants to stay a couple of minutes, I will take their name. If not, they will. I will send in any case a message to Sophie Darmagnac on my suggestion, so that in the end, if some of you are willing to spend some time with me by spring for feedback and discussions and good ideas to improve this case study for next year, it will be a pleasure. If not, I will do it in any case because I know I need to improve. My first target is to reduce the timing or to convince Sophie to spend 2 hours for the case study. Thanks a lot. Please take care. Have good times with your family, friends, neighbors. I hope you will spend Christmas and or New Year's Eve with some other people. Take care of yourself and be safe. Thanks. goodbye for those who need to leave now again. And if some of you want to stay, we can have a few minutes discussion.
Thank you.
Thank you.
Thank you. Bye. Goodbye.
Thank you.